Last topic for today shouldn't take us that long to cover. So I'm gonna go ahead and show you this definition. I want you to write it, and then we'll discuss it and do an example with it. So I'm gonna go ahead and pause the video so you can kind of have some time to write this down. Last topic for today, like I said, as you can see here, it's called the Intermediate Value Theorem. Okay, so let's first kind of try to digest this information that's on the board. Okay, so it says, first thing, there's a few requirements. We have a function, and that function has to be continuous. We literally just discussed the idea of continuity. Okay, so that means we don't have any sort of breaks whatsoever. Cool? Now, what's interesting to me, bless you, is that they're actually talking about continuity on an interval. Okay, and they're telling you that if you have a closed interval, and I find that to be very peculiar for them to say that. Okay, what does it mean to be a closed interval? Say that one time. Okay, so not only is it continuous in between, but you are to consider the endpoints also as part of the continuity, which kind of contradicts the definition of continuity at a point if you really think about it. Because we just discussed the idea that in order for you to have point continuity, you should have a limit exists, right? Is it possible for you to have a limit exist at the endpoints? No. Why? Because in order for a limit to exist, there should be two sides, a left and a right. Are you guys with me? So do you understand, like in math, when it comes down to writing down theorems and definitions, we're very careful about what we mention, right? So us saying continuous from A to B kind of contradicts what we already know. So we have to say on a closed interval so that you understand that we know that mathematically you're not going to be able to prove it, but I want you to consider that A and B does exist indeed. Fair enough? Okay. Second part. Very important. It says the value of f of A cannot equal the value of f of B. So what does f of A and f of B represent as far as the function goes? I'm sorry? The y values, the outputs. So it's saying the endpoints, the outputs of them are not the same. Cool? It's necessary for this to be true. Okay? And then lastly, it says k is any number in between f of A and f of B. So so k should represent also an output. Do you guys agree? Okay. So that's the first requirement. If all those requirements are met, then the following, we can assume the following. It says then there must be at least one number c that happens to be in between A and B. So C is part of the domain. Are you guys with me? It's part of the input. There has to be at least one value such that the input of that would create K. Why is all of this true? Why? Like, why is it enough for, like, because if we call something a theorem in math, it means that you cannot come up with an example that would contradict it. Are you guys with me? So why is this true? What makes this entire statement, and it comes down to one word, true? Starts with a C. Continuity. Because it's continuous. Because it's continuous, that's why we can say this entire statement. Are you guys with me? I try my best to give you, like, this is not the only example, right? So, for example, as you can see in the diagram that I put here, I have my closed interval between A and B, right? And then I have endpoints that are not the same. Cool. Which means this is my output of f of A, this is my output of f of B. And then I chose something in the middle, right? I just, instead of labeling it K, I just called it f of C. Are you guys with me? So you can see that everything basically, and I've created this little box. Every single value in that box that I created has to exist because it's continuous. You guys with me? Every single y value exists, every single x value exists, and it could be more than once. It doesn't have to just be once, but you are guaranteed by IVT to have at least one value that would create that. Cool? Now, first question I have for you. Does this tell you how to find it? No. This theorem is what is known as an existence theorem. All it tells you is that it happens, but it doesn't tell you how, like how to find it. Like what procedures would you need to do to figure out where it is happening. Are you guys with me? Now, that's where your algebra skills come in, if necessary, to solve something for it. You guys with me? If all they're asking you to do is like prove that this number exists, then you just have to kind of mention it. But if it says find that number, then you use algebra. There's no calculus involved. Okay? So here's an example that I have. And I know it's a little, the handwriting is a little, let me cover the bottom so I can see. All right. talk this through. There'll do a little physics involved in it. Okay? So velocity of a particle that's moving horizontally along the x-axis is given by a continuous function v of t. All right. First things, I gotta be honest with you. I didn't really need to tell you that the function was continuous. Okay? Is anybody taking physics? Yes? Okay. What's velocity? Speed over what? Speed with direction. What speed? The rate of change of what? Position over time. You with me? Okay, so it's describing is telling you we have some velocities, right? Because I don't actually have a velocity function for you guys. Fair enough? So I'm going to have some data about it. Cool? What's up? Hello? Cool. All right. So then you're told that you have some information about the velocity at specific times on this table. Fair enough? All right. It says the velocity is measured in feet per second, and selected values are on the table. Cool. So we are told that the velocity when time is 0 is -3, when time is 2 is -1/2, when time is 5 is 2, and when time is 8 is 1. Cool. All right. Explain why there must be a time in which, in between 2 to 5, where the particle is at rest. What, first of all, there's a few things we need to make sure you understand. I don't know that everyone's taking physics. What would it mean for something to be at rest? Not moving. If something's not moving, that means that their distances are not moving. So over time, that means that their velocity would equal to what? 0. Okay? So you are being told to explain why. They're not telling you whether like it's a lie or not. They're telling you this is true. Explain why there must be a reason why you're at rest in between 2 to 5. Can you explain that to me? Yes. Why is it a closed interval? Okay, so you're analyzing the velocities at 2 and at 5. Is that what you're doing? Okay. So the velocities at 2 is -1/2 feet per second. The velocity at 5 is 2 feet per second. Okay, continue. Say that a little louder, I'm sorry. What's continuous? The velocity? Okay, the velocity is continuous because okay. So if you analyze this from a physics perspective, it's impossible for you to skip a number like a velocity. Like you have to, in order to go from like 0 to 60 when you're driving, you have to hit every single digit in between 0 to 60. Are you guys with me? But I gotta be honest, even if you don't know physics, what in the problem could you use? The fact that it tells you it is continuous. Are you guys with me? The problem says it's continuous, right? So now, what are you gonna write to prove that there is a rest? IVT, okay, since the velocity is continuous, the velocity at 2 is negative, the velocity at 5 is positive. The only way that I can go from negative to positive is if what? I have to cross 0. Crossing 0 guarantees what? That I'm at rest. Therefore, because of the intermediate value theorem, I can 100% tell you that I am 100% at rest somewhere in between 2 and 5. Do I know exactly the time? No. They tell you to find it? No. Do you even have enough information to find it? Absolutely not. Okay? Do you kind of see what I meant by existence theorem and how you would use it? Cool? All right. Any questions about anything on this specific topic? Let's see. So I put like a lot of like all the sentence. So like I put to be at rest, I explained it. B of t has to be 0, right? So then I put the velocity is -1/2 when it's at 2. The velocity is 2 at 5. Since velocity is continuous, every value between -1/2 and 2 must exist, right? Therefore, the IVT would guarantee that the particle is at rest at least once in between that interval. No, because just because you're continuous doesn't guarantee you're going to hit a 0. You have to mention the fact that you're switching from negative to positive to guarantee that you're at 0. Sure. Yeah, absolutely. Yes. Just what you're analyzing, right? So in this case, the entire function is continuous, but doesn't have to for the entire, like, depends on the problem, but it definitely has to be continuous for the specific part that you're being asked about. Cool? Any other questions, guys? Are you sure? Okay.